I think about this a lot. A year ago, a company that should have known better told a reporter that there were 3 billion internet-connected electric toothbrushes vulnerable to a botnet attack. There are several problems with this scenario. One, the toothbrush probably uses Bluetooth Low Energy, or BLE, to connect to a mobile app. The mobile app connects to the internet. If the toothbrush itself had a vulnerability, who cares? Okay, maybe that's an overstatement. I mean, unless the flaw can be exploited through the app and then through the Bluetooth connection, the exploit isn't going to reach the device. So it doesn't matter if it's one device or 3 billion. My second problem with that is that I doubt there were 3 billion internet-connected toothbrushes at the time. But I digress. My point is, we should be focusing on real examples of internet-connected devices being vulnerable to things like remote code execution. Fortunately, my guest in this episode is a return guest, and as always, he brings receipts from his recent talk at Black Hat USA 2025. This is a story about accessing surveillance cameras and taking full control of them via man-in-the-middle attacks and remote code execution. I'm Robert Famosi. This is Error Code.
I am Noam Moshe. I am the team lead for Claroty Team 82, and today I'm going to talk about turning camera surveillance on its axis, basically how we act as camera solutions. So Claroty is CP in the CPS market, protecting cyber physical solutions. We try and analyze and protect various fields of devices with some physical consequences, talking OT, medical, and of course IoT. Specifically, my team, Team 82, is a research team. Our job is to find vulnerabilities and uncover them and securely disclose them to the vendor with the goal of protecting the entire wall, basically.
This is my third interview with Noam, and he always has amazing stuff that he talks about, and usually at Black Hat USA. Well, at Black Hat USA 2025, he presented about a specific vice that is very common. In fact, you probably see it in offices and stores and maybe in your home today. It's an access camera, which is used for surveillance purposes.
So for example, if you think of an office layout, you want to make sure that only authorized personnel are in. You want to cover your entries, your exits, making sure everything is okay. So basically, think of it like a guard station surveillance system, allowing you to gain full control and full visibility into your physical assets, physical locations. And like you said, Axis mainly is aimed at more enterprise level, meaning it is not a home user kind of IP camera. It is more robust, it offers more features, that is more aimed at more sophisticated enterprise level equipment and companies.
So you've got all these toys in your office, and you could play with any one of them. How did you settle on a surveillance camera?
So it's interesting. We saw a very big trend. It started in the US, but it's seen more and more in Europe, UK, of banning like certain IP camera solutions, mainly Chinese-based solutions, meaning, for example, in government institute, in medical, educational, etc., you are disallowed from using a vast range of cameras that are manufactured and made, and the company is based in China. And this left the field with less and less options for the end user. Meaning, if you're an enterprise and you want to buy video surveillance solutions, if in the past you had 20, 30, hundreds of different options, now you have way more, way less. And this was what triggered our research, trying to understand what is the field that the users are left with. And this was when we reached Axis, which is one of the leading vendors in that field. And yeah, we believe at the end of the day, Axis is seen in many different enterprises, organizations, medical institutes, you name it.
So Axis, it has its own operating system. How many devices out there are big enough that they feel that they need to have their own OS?
So it really depends. I mean, at the end of the day, when you're talking video surveillance, you're talking tens, maybe even more different product lines and devices. And because of that, Axis chose to implement what's called Axis OS, which is, of course, Linux-based, but it is shipped with the entire Axis ecosystem. Now, it really depends. How common it is really depends. Many companies choose to only do Linux-based, and they might have an image that is like the baseline for the products. However, yeah, it is like you do see commonalities between different product lines.
So you were looking at the Axis cameras and you found something called access remoting.
On its core, it is a binary protocol. It comes into flavors. There's the main TCP-based protocol, which is binary, but it is based on JSON. I mean, after you pass the binary part, at the end of the day, there's JSON payloads being passed, which basically enables clients and servers in the Axis ecosystem to communicate with one another. So basically, let's say you have an Axis server that controls the entire camera fleet you own, and manages them, make sure their configuration are set, to that from upgrade, you name it. Then you want to be able to connect to this server, and you do it via the access remoting protocol. And to do that, you have your very own native Windows application that is written in .NET, which basically allows you to connect and communicate with your server. Now, we discovered that within this protocol resides many vulnerabilities that we managed to uncover and disclose to Axis. However, the most severe one is a deserialization vulnerability. Basically, like I've said, the core base of the protocol is based on JSON payloads that basically tell the server, hey, this is the kind of functionality I want to invoke in you. So let's say, for example, a client wants to authenticate. Then it tells the server via RPC, hey, I want to do an authentication method. And to do that, the server needs to somehow create objects that were sent by the client. So let's, for example, the clients want to authenticate, then they send an object of authentication information. And this process is called serialization and deserialization, basically taking an in-memory object and serializing it to be able to be passed over wire, meaning somehow translating it to text-based or binary-based representation. And then the servers need to reconstruct it and create a real-life object in its memory. This is the deserializer process. And in it, many vulnerabilities could reside, and we discovered a few in Axis that enables clients to basically create malicious objects on the server, leading to code execution.
So what would be an example of somebody taking advantage of this vulnerability? How could they use it maliciously?
So we devised two different approaches. The first one is a man-in-the-middle approach. Basically, if you are able to cause a client to connect to you instead of a real server, you are able to fully man-in-the-middle the connection. Then you're able to both decrypt it because you are in the middle and you are able to act as if you are both endpoints and fully decrypt the code traffic, and inject your own payloads into the communication, meaning impersonating the client and sending a message on their behalf, or impersonating the server and sending a message to the client on the server's behalf. And because this change with the deserialization vulnerability could lead to full remote code execution on both the client and the server, meaning if you are able to man-in-the-middle connection between Axis client and servers, you are able to execute code on both endpoints, which is very, very cool. Now, in addition to that, once you control the server, of course, because the server manages the different cameras, you are also managing the different cameras, because at the end of the day, the server's purpose is to control cameras. And once you execute code on the server, you are able to do actions with its permission, meaning you are able to inject your own code and pivot and leverage your way into the different cameras, IP cameras, that are managed by the server.
And would they be just observing what's seen by the camera, or can they actually move the camera?
When we started the research, one of the things we tried to do is set up like a James Bond style operation, basically injecting incorrect feed and being able to do like spy stuff. So this is completely possible. You are able to control the camera feed, move it, whatever is supported by the camera. However, there's even a deeper layer because you are able to execute code directly on the camera, meaning you are able to pivot and get access to the network the camera is located in. So think of it as an attacker attacking the server and then pivoting to all the cameras, the IP cameras in an organization, being able to fully control them, move laterally, you name it. And we do see an increased number of attackers targeting IoT and cameras in specific, both iPhones, stuff like that, basically targeting different IoT equipment to pivot into networks, gain persistency, and stay undetected.
So with something like that, could it be protected by network segmentation?
So yes and no. At the end of the day, you need the Axis server needs to control the cameras. This is the use case. This is legitimate, fully legitimate. So you cannot segment the Axis server from the cameras. It must stay connected and must be enabled in the firewall. So you won't be able to protect against that. However, and this means essentially that once the attacker gains control over the server, they are able to pivot to the cameras. However, after that, segmentation comes into play because if you segment the cameras, meaning you protect against an attacker that is on the camera and trying to pivot into the network, then you can segment the network and make sure that even if they got to the cameras, they are not able to move laterally in the network. So for sure, network segmentation is A, super relevant and could help protect, and B, personally, I think this is one of the better way to protect your networks. But you won't be able to protect the cameras because at the end of the day, this is the legitimate use case, what's called the business logic. This is what's supposed to happen.
Noam mentioned that there are two things you could do with this exploit. We talked about the man-in-the-middle attack. What's the second one?
So the second one, and I think it's more interesting, is the ability to do pre-auth RC.
So pre-auth, that's basically granting you permission to go in and do whatever.
Basically, it allows you to execute arbitrary code, OS command, anything on the Axis Device Manager or Camera Station, which are the Axis servers, without needing any prior knowledge, without needing credentials, user interaction, nothing. All you need to do is to be able to communicate and talk to the server via the Axis remoting port, network port. So you need to be able to access it via network. And once you do, you are able to fully execute code on the server and once again pivot your way into the cameras managed by that server. Basically, the first vulnerability, like the vulnerability chain, we'll call it, requires user interaction, meaning the user need to connect to your man-in-the-middle server, and you need to somehow sit in the middle and inject payloads into the traffic. The second vulnerability is the missing link. Basically, it allows you to exploit the deserialization vulnerability without needing authentication. Generally, Axis, and specifically the Axis remoting protocol, is fully authenticated, meaning the first thing you need to do is authenticate to the server and tell them, hey, I'm a legitimate user. However, by exploiting hidden routes, we managed to find a way, like an edge case, in a fallback proprietary mechanism that enabled us to bypass authentication needing. Meaning we were able to bypass the authentication and then inject our deserialization payload, resulting in full pre-auth remote code execution on the Axis servers.
So Noam and his team found multiple vulnerabilities, some of them being severe, some of them being less so.
Exactly. Many times, I think you could see it in adversaries and vulnerability researchers alike, real-life vulnerabilities are more complicated than a one-and-done kind of vulnerabilities. We do see them sometimes. Sometimes you have pre-auth OS command injection that you just send on an HTTP payload and that's it, you're done, you're root. However, in tougher targets, and Axis is for sure a tougher target, and more hardened, more security-minded, there is no one-and-done kind of vulnerability. Usually you need to chain a few vulnerabilities together, basically leveraging different primitives in order to fully exploit a target. And in this case, this is a classic case of chaining vulnerabilities together because we have a primitive that allows us to basically bypass to the Axis remoting protocol, allowing us to talk in the protocol. Then we are able to exploit different vulnerabilities that allow authenticated users to exploit the deserialization vulnerability, giving us the pre-auth RC. Or on its own, each vulnerability, while still severe, is not the holy grail, which is pre-auth RC. And I think this is a common case in real life hacking, where you need to chain these primitives together and basically leverage your way into gaining the holy grail.
So how long does this process typically take? Like, it's August of 2025, and you gave your presentation here at Black Hat USA. When did you begin, and how long did it take you to realize that you had something, and what was the disclosure process like with the vendor?
Like you said, I think like the research process is 3 parts. The first one is on the research end. Basically, you need to take a look at the product and take it apart, play with it, reverse engineer it, and try and uncover vulnerabilities. Once you have the vulnerabilities, basically is the first part. You need to actually do the hacking part, which is, in my opinion, like the hardest part. After that, we usually move to the second part, which is constructing like a full report, POCs, basically having a full kit for the vendor to be able to investigate and understand the vulnerability. Because if we have a vulnerability and we won't explain it to the vendor, they won't know how to fix, what to fix. I mean, it's a very big hassle if we don't compose it in a correct way. And so this is the second part, basically taking the research, which we do, like it's a lot of work, reverse engineering, scripting. It's not documented, and starting to document everything. And this is the shortest part. And then we move to the third part, which is the disclosure part. We contact the vendor. We tell them, hey, we're security researchers, we're vulnerability researchers. We uncovered vulnerabilities in your product. Here is the full report, all the technical details. We are here. Let us know if you are able to reproduce. And let's work together to make sure you offer a fix for your customers. And now this varies because there are some vendors that are super professional, super quick. And I can tell you that for sure Axis is one of them. I mean, I've done a lot of disclosures to probably almost 100 different companies. And Axis is between one of the best I've ever had. Their security mindedness, their like mission to make sure the rest is perfected. Kudos to them. I really don't give it lightly. So we've worked with them. We basically disclose the vulnerability to them. And then it's their part. They need to offer fixes and like make the changes in the code to make sure their devices are protected. So after that, we have a patch that users can apply to their servers. We issue vulnerabilities, and then we wait. We give users enough time to make sure their devices are protected. We don't want to release technical like details about the vulnerability before users had ample time to patch and make sure they are protected. So if we take the Axis research in specific, we started working on the Axis research beginning of this year. And it takes a lot of time to reverse engineer, find the vulnerabilities. However, I can tell you that from when we disclosed the vulnerabilities to Axis until when there was a patch, it was between a few weeks, like 1, 2, and maybe a month. It really depends for which vulnerability.
Right.
And this happened around April to May.
Okay, I just want to disabuse people on this idea that it's very quick to find a vulnerability, and it's very quick to get it patched by the vendor. All not true. It looks like it took between January and April for all of this to transpire.
I mean, even this was fairly quick. We have research that is going on for half a year and even more, a year even. It really depends on the architecture of the device and what kind of vulnerabilities we uncover. I can tell that even the disclosure process is sometimes a bit longer because sometimes the vendor needs more time to make sure they offer a correct solution to the vulnerabilities we've uncovered. And we work with the vendor to realize that they simply don't want to fix it and are like telling us, oh, we are dismissing it. But some vulnerabilities that require architectural changes are harder to fix, and it does take more time.
I guess that also depends on the maturity of the vendor. For example, some manufacturers may not have the ability to absorb security vulnerabilities from the outside world.
It for sure does. Like we see companies that are way more security minded and have like CERT team that handle like researchers finding vulnerabilities on the product. For example, Axis has a dedicated page on the website where you can contact them and disclose vulnerabilities. Some do not. It really depends on the maturity of the product and like the past experience with researchers. But I can tell you that more and more companies are starting to put the focus, put the time, people, and money into making sure the devices are protected because they are realizing this is an industry standard and should be required.
In his presentation at Black Hat, he showed a picture of a wall of devices. It's like a full range of devices that are out there in the world today.
If you're in Tel Aviv, feel free to jump to our offices. You'll enjoy it. Like we have like a wall of like actuators and PLCs and HMIs, and like we did an intercom like IoT style research on like different intercom devices and medical. And of course, we have like a wall of shame of devices we bricked in our research. So we have a lot of devices over the years. Like if you'll see my eBay shopping cart, all the history.
So with all these devices that you have to work with, are you focusing on enterprise devices or are you also looking at the consumer devices?
We are focusing on anything that is relevant and heavily used. So in our research, it really depends. That's the full answer. We looked at home intercom systems. We looked at enterprise intercom systems. Really, what we're trying to do is to analyze and look at the common, interesting, heavily used product out there. And it could be enterprise, it could be consumer, it could be user, the entire array.
And is there something fairly common that you encounter in your research? Like, is there a go-to when you're opening up a device for the first time and you immediately suspect that there may be vulnerabilities here?
So obviously every research is like a new experience and it really depends on the device, architecture, protocols, anything of that sort. I can tell you that like in general, one of the things that I love doing the most is when it comes to like cloud solutions and cloud services is to take a look at it from the device's perspective. So let's say you have a cloud that controls IoT equipment. Making sure your cloud solution is like your cloud service, let's say application or whatever, is secured from the user's perspective is very well known. We have like making sure you do authentication, authorization. It really is a solved solution. Like you have so many frameworks, so many best practices. Like every user should have a password that is composed of like 12 letters, the special characters, etc. So it's really well known and should be implemented correctly. Making sure every request is done from an authorized, authenticated user. However, that's not the same for devices, because at the end of the day, like if you have a solution that like control your devices through the cloud, the devices also talk to the cloud. And making sure you do authentication and authorization for a device is way harder because the device doesn't have an email, it doesn't have a password. And just the idea of thinking that there might be a malicious device attacking the cloud solution is not something many software developers think about, because they think of a device as a closed box. It's the code that they've written. It shouldn't try and attack them. But by reverse engineering the device and discovering the API, we are able to basically try to use the device's API to find vulnerabilities on the solution. So in general, like one of my favorite type of vulnerabilities when we're talking about like some kind of cloud services to control devices is to take a look at the cloud from the device's perspective.
Noam mentioned that there are certain skills that are needed for this type of work. And like IT and OT, it's like, yeah, but OT, it's still its own thing.
I mean, it does require specificality, like very specific knowledge base. Anyway, like if you're technological, you can learn anything, but like a lot of it is like if like learned knowledge.
Yes.
So it's like over the years you get more and more into that, and you need to be able to like connect the dots, which is hard in OT. Yeah, I think in general OT was built on a time that there was no like common idea of an internet and IP connectivity. Like at the end of the day, when OT was starting, invented, like many devices that are still in use today, they were built with serial connection in mind, where everything is more secure because you're talking wire to wire. There's no attackers that can connect the IP. That was entirely new. And I think this is one of the reasons why we see so many like vulnerabilities in the OT space that are similar to old school vulnerabilities in the IT space. Because the same transformation happened, like the fact that the internet and devices are exposed and like people can communicate with them is not new, but it was not designed with this in. Now, in general, I think one of the reasons why OT requires a lot of knowledge is because it is very not closed source, but like less public knowledge. I mean, now it's better, but at least if you go like a few years back, like there was no public knowledge, open source libraries. There was always nothing. You had to, like, if you wanted to work with the device, you need to get certification of that device from the manufacturer, and it only talks with that device software and nothing of that sort. So I think like the world of open source, open knowledge in OT, at least in recent year, it is developing, but it is still not there as if we're talking about IT. The research on Axis is super cool. It showcases real life vulnerabilities that affecting thousands of companies. But it showcases bigger ideas. Like, for example, if a protocol is wrapped with encryption, like TLS, it does not mean that it is necessarily more secure. If it requires authentication, it does not mean that it can be bypassed. And in general, I think like the main idea is that everything has vulnerabilities, and you should understand what is the attack surface that you open onto your networks when you expose services online.
I'd like to thank Noam Moshe for coming on the show and talking about his latest research presented at Black Hat USA 2025. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. We'll have more on Volt Typhoon, Salt Typhoon, and hacking utilities supply chains. Subscribe today. I don't want you to miss out.